So in this first example, which is like problem 1 in the review, we're given that according to the Census Bureau, the mean number of children per family in a U.S. household in 2019 was 1.93. So that's going to be a population mean because it's coming from a census. So mu is 1.93. Assume the population standard deviation is 1.1. That is going to be sigma. And then we take a sample of 50 households. That is your sample size n. And we want to know what is the probability that the sample mean, that's an x bar value, as opposed to an individual x value. What's the probability the sample mean number of children is less than 2? Round to 4 decimals. So what we want here is we want the probability that x bar is less than 2. And we'll use normal CDF to find that, but we first need to find sigma x bar, the standard deviation of the x bar values, because we're dealing with x bar values. So that's sigma over square root of n. Our sigma is 1.1. Our sample size is 50, so we're dividing by root 50. And if you enter this in the calculator, you get 0.1556. So now to find probability that x bar is less than 2, this is normal CDF. And then remember what this looks like on a bell-shaped curve here. You've got that 1.93 in the middle, which is the mean of the bell-shaped curve, and we want to know, well, what's to the left of 2? So this area here. So our lower cutoff is going to be negative infinity. We could use negative 10,000, just a big negative number. Our upper cutoff is the 2. And then we need to put in our mean and standard deviation, 1.93, and then our 0.1556. So don't use the 1.1 because you get the wrong answer. So let's go to the calculator. Second variables. We want normal CDF, number 2. Our lower, I'm going to use the 10,000. You can use the negative 1 times 10 to the 99. You should get the same answer. Our upper here was 2. Our mean, 1.93. And our standard deviation, 0.1556. Paste it, 0.6736. So about a 67% chance that that mean of a sample of 50 would be less than 2. What is the probability that the sample mean number of children is between 1.5 and 2.5? So again, that's an x bar value. So we're asking what is the probability that x bar here is between 1.5 and 2.5. So this will be normal CDF. Our lower cutoff now is 1.5. Our upper cutoff is 2.5. And we're adding the proportion or the probability of the data between those two with a mean of 1.93 and a standard deviation of 0.1556. So let's key that in. So second variables, normal CDF again. Our lower now is 1.5. Our upper is 2.5. And mean and standard deviation, those stay the same. Paste it, enter 9970. So 0.9970. So 99.7% chance that the mean of a sample would be between 1.5 and 2.5. Next up, we're finding a percentile here. So remember that a percentile is the value with that percentage below. So the 85th percentile of the sample mean, so the 85th percentile of the x bar values, we want to find that rounding to 2 decimal places. So remember, 85 percentile means that we've got 85% of the data, which in this case is x bar values, are below. So in other words, that's telling you that the left area equals 0.85. So to do that, we're going to use inverse norm. So our left area is 0.85. And then we need our mean of 1.93 and our standard deviation of 0.1556 because we're dealing with X bar values. So let's key that in. So we go to second variables, want inverse norm, which is number 3, area 0.85, mu is 1.93, and sigma 0.1556. And if you don't have this menu, then it's automatically left area. And that gives us 2.09. So 85% of the sample means are going to be below 2.09 children. Would it be unusual for a sample mean, an X bar value, to be greater than 2? Round answer to 4 decimal places. So what's the probability that X bar is greater than 2? So that's from 2 to the right. So normal CDF, our left cutoff is 2. Our right cutoff, a big positive number. I'll use 10,000. Our mean, 1.93. And our standard deviation, 0.1556 again. And let's compute that. So second variables, we want normal CDF. So our lower is 2, our upper 10,000, our mean 1.93, and standard deviation 0.1556. Paste it and enter. 0.3264. 0.3264. And remember, unusual is if the probability is less than 0.05. So this is greater than 0.05. So it is not unusual because the probability of the sample mean being greater than 2 is 0.3264. And anything greater than 0.05 is not unusual. And then the last part, do you think it would be unusual here for an individual household to have greater than 2 children? And explain. So we're going to assume our population is approximately normal. That means we can use normal CDF to compute that probability. So now we want probability X is greater than 2. So our lower cutoff is 2 in normal CDF. Our upper cutoff, infinity, we'll use 10,000. And then our mean, 1.93. But since it's an individual X value, we use 1.1 for the standard deviation instead of the 0.1556. That's for X bar values. So let's go ahead and key that in. So second variables, normal CDF. And now the thing that changes is our sigma to 1.1. Paste and enter. 0.4746. And that is greater than 0.05. So it would not be unusual for an individual household to have greater than 2 children, since the probability is 0.4746. And that's greater than 0.05. Have to be less than 0.05 to be unusual.